So, a piece of good news and a piece of bad news. So the good news is we are a pretty small class. The bad news is that because this is such a small class, this section might not be taught, and only the other section might be taught.
Which is that in the afternoon?
That is in the afternoon.
Okay.
And it's a brutal 4 hours in one block.
Okay.
But I see a lot more people here than actually registered. So
I registered in the last moment because
Okay.
my declarance was pending for months.
Okay.
So I just registered.
So you just registered, good. And who else didn't get declarance yet?
Yes.
Okay, so it's like 2, 4, 6. You as well in the back?
Yeah.
Okay, 7. Okay. So that would change this quite a bit. And when do you expect this to come in? Declarance and stuff.
I should join.
Should be any moment or like, okay.
And City is coming as well, so she should be on the way.
Uh-huh.
I don't know if she's registered.
Well-
She just got a declarance on
Okay.
Friday.
Let me just take your picture, and so that I can make the point that we have enough people for class.
You justify it, yeah.
Yeah, so because last week I got an email from Craig Knobloch, and he's like, are we even going to teach this class because it's so small? But it looks like we're like not too small, and I think the other consideration is if we cramp everybody into the other section will be very large because they are already 26 registered, and I think the maximum number is 37. I wouldn't know how to fit 37 people in here though.
Oh, that would be
insane.
a nightmare.
And
It is fabulous size.
Yeah, that was actually the reason why I met only 8 people in this class. I thought I went to the wrong class.
right, because it says only like
It must be a smaller class, right?
So that means, in a sense, that we're going to be able to make this quite interactive, and I think like this is one of the things that I was also kind of looking forward to. So we're going to have these 2 days, and like one on Monday and Wednesday, and I think we're going to like shift it back and forth a little bit because of travel schedules and stuff like that. But in general, I think we will kind of reserve 1 day for lectures and 1 day for like discussions and some hands-on stuff, and maybe we're going to have some. So I feel like we're probably going to rather do a couple of quizzes instead of like a midterm. If everybody agrees to do that, I think it will be a lot more digestible. And then for the final will happen in May, but will also be about the entire class. So there's not going to be like a before or after. So it's not like just until the midterm or from the midterm. The TA, Li Sheng, should also be here. I don't know why he's not here, but I'll talk to him about that later. And and so I think what we're going to try to do, so Li Sheng and myself, is going to come up with we're going to try to come up with a couple of interesting machine learning exercises and experiments that he will probably mostly discuss with you guys. And that will also be on 1 day. So so we have 2 hours of lecture plus maybe half an hour, 45 minutes on the other day with lecture, but mostly on the other day we're going to do discussions, and we're going to do some practical exercise discussion and like homework and some quizzes. So we're going to post every week a couple of like papers to discuss. There will be a discussion board, or I think there is already on Blackboard, where you can post questions to other students and to me and my TA, and we're going to try to answer those questions as fast as possible, but like rely on your other fellow students to discuss these machine learning questions. And then we're going to have like a circle where everybody gets to talk about like what they read and what they experienced with the paper, and so there's no pressure for like there's no correct or wrong answers. It would be just good if like everybody has the feeling to like I want to participate. I don't want people to just sit in and like wait out the 2 hours. We want some active discussions. And I think with the class size that we have, I think that's very doable. And I might actually be able to remember everybody's name, which is not always a given if like we have 50 people and yeah. So this is, I think could be very exciting. I think we have enough people to actually do a class. So I'll make that clear, that we should go ahead with this. I also had like a couple of comments that the other section is actually not, like schedule-wise, not as good or like not as accessible for some people. So we, I think it's better if we split it also. Like a 4-hour block just didn't seem appealing to me actually, because like I get tired as well and make mistakes or get bored. All right. Great, so let's start with an introduction lecture today. So first of all, I'd like to give a little bit of a rundown, and some people know this already. So who I am, my name's Stefan, and I'm a research assistant professor here at USC in computer science. And my primary workplace actually though is the USC Institute for Creative Technologies, which is off campus, which also makes it a little harder for you to get like access to an office hour. But there are free shuttle buses to ICT, and if you let me know in advance, we might be able to like set up a meeting after the lecture or before the next lecture or at ICT. And I don't have an office here on campus, so it's not as easy for me to just set up an office hour, okay? So just bear that in mind. If you have questions, just let me know at the end of the class. Send me an email to set up a meeting. I got around a little bit. Before I came to USC, I worked at Trinity College in Dublin. I worked in Japan with those fancy robots at ATR. We had this Geminoid robot there that basically looks like a real human and tries to like replace or like be a sit-in robot for a professor there, Hiroshi Ishiguro. And I got my PhD from Ulm University in Germany. I'm not German though, I'm Austrian, very important distinction there. And so yeah, that's kind of like my the transition that I did make, and I would like to show you a couple of videos about ICT. ICT is this place, really cool technology in Playa Vista. There are free shuttle buses again, so try to find where those leave from. I do not know where they leave from. I think it's like somewhere over there. Okay. And Vivian Hall, is that the new, like,
Yeah.
because they moved it at some point?
Yeah,
and,
just the front V-core.
Okay, great. And so we do these really interesting like gadgets and technology at ICT. So one of the people that graduated from ICT was Paul Malaki, and he came up with the Oculus Rift, if you remember that. And we like paid people to make fancy videos, so I would like to show you those videos. And it's just, yeah, it's also a good reason to test the audio, which does not seem to work.
University-affiliated research center working in collaboration with the Army Research Lab. The Institute for Creative Technologies, or ICT, was born out of the Army's desire to raise the bar in simulation. To tackle that challenge, we combined the magic of movies and the engagement of video games with world-class academic research to create immersive environments and experiences. But that was just the beginning. Today, ICT has established itself as a leading force in creating experiences that matter. Through research and development, ICT creates experiences that revolutionize how we teach, train, heal, and help.
So, what would you like to talk about today?
The future will be virtual, augmented, and wearable. At ICT, researchers know that all this technology will only have value if it is accessible and meaningful to the people who need it most. Our scientists are part of USC's deep and wide-ranging research and development expertise, and are award-winning leaders in artificial intelligence, graphics, virtual reality, and narrative. Their mission is to create immersive technologies that make it out of the lab to solve real problems in the lives of soldiers and civilians. ICT's work with virtual humans creates digital characters that look, sound, and behave like real people.
Hi. Hope you weren't waiting long. Welcome to SimCoach.
They act as tutors, coaches, and role-play partners to improve student performance. Our extensive research and focus on the human dimension led to a series of games and immersive experiences that provide cultural awareness and leadership training used throughout the military. ICT's innovations in creating realistic environments make it possible to create virtual reality exposure therapy aids for the treatment of those suffering from post-traumatic stress. A platform for sensing and understanding emotions in real humans can make virtual characters more realistic, but also helps clinicians identify signs of depression and respond effectively. All this is made possible because we work to make our research a reality and put it directly into the hands of users. This might require transforming off-the-shelf devices for new, cost-effective, and beneficial uses, or deploying innovative technology that changes the face of education and entertainment. Virtual and augmented environments can be used to help people in the real world. ICT has already provided valuable ways for people to interact with digital technology. Now, we look ahead for the next generation of solutions that benefit students, service members, and society as a whole. This is the power of cutting-edge science, focused on the human dimension. This is the power of ICT.
So yeah, fancy videos and dramatic music. So this is kind of like what ICT does in general, and I also brought a video about like my particular research there, and I'll get into that in a little bit more detail in a second. And I'll also like try to intersperse the lecture with some of my research that's ongoing and done before, like to just illustrate uses of the theoretical parts of the machine learning that we're going to discuss in this lecture. So this is going to be about SimSensei.
The University of Southern California Institute for Creative Technologies brings computers to life. Our Virtual Humans project is an internationally recognized research and development effort to create independent, interactive characters that look and act like real people. In research settings, ICT Virtual Humans advance our understanding of how people think, feel, and behave. Outside the lab, virtual humans can live in everything from laptops to mobile devices, and are used for training, therapy, entertainment, and education, with new uses created every day. ICT Virtual Humans are learning to understand, speak, gesture, reason, exhibit emotions, and even recognize and interpret the verbal and nonverbal cues people relay in conversations.
Well, pushing them was, definitely wasn't the right answer.
You know what, sir? I get it.
To create this incredible experience, ICT researchers integrate computer graphics and artificial intelligence tools and techniques. The result, interactive virtual humans with minds, faces, and bodies of their own. These collaborations have led to an advanced modular system that allows for the easy creation of many aspects of a character's performance. These modules can convert a user's speech into text that a virtual human can understand, and create dialogue responses that allow the virtual human to respond naturally to the user. The animation of characters is achieved with Cerebella and SmartBody. They allow a virtual human to automatically generate behavior that corresponds to speech, using the behavior markup language. All of these tools are an important stride forward, and used together they represent an important leap in the field of virtual humans. ICT helps other researchers to mix, match, and modify these capabilities to incorporate autonomous, conversational digital characters into their own lines of study by releasing the Virtual Human Toolkit. This allows for a crowdsourcing of further development of tools, and as technology moves forward, our toolkit also evolves, becoming more capable over time. ICT Virtual Humans are already helping teachers create educational programs, training soldiers on negotiation and leadership skills, and allowing future clinicians to practice conducting interviews. As virtual humans become more advanced, they will become ubiquitous not just in education and health, but in entertainment and in our everyday lives.
Hello.
Hi, what's up?
My throat hurts.
I'm sorry to hear that you have a sore throat. Is it really painful to swallow?
Virtual humans are the future of interaction and engagement. ICT is leading the way not just to research and develop these characters, but to make them widely available.
So, what do you think if we work on virtual humans, like where could we use machine learning? Do you have an idea for that? We had an entire class.
Yeah.
So, would you like to mention some stuff?
Well, machine learning was from understanding where human-to-human interaction happens and translating it into what human-to-artificial human interaction can happen.
Yeah, so one of the things that I work on is like I provide these virtual humans with a new set of eyes and ears. Like we try to give them an insight of like how humans behave. Like what does this facial expression mean? What is the stance? Like am I leaning forward towards the virtual human? Does the virtual human is it able to realize that I'm engaging with it? Or if I like turn my head away constantly and I like don't look at it for a while, does it understand that I'm disengaged and that it should like try to re-engage me into a conversation? So like we're trying to build these methods to better understand and better target virtual human abilities towards human communication. Hey, sorry about that. And so we try to provide these virtual humans with a different set of eyes and ears, as I said, and what we're trying to understand really is human communication. And so through this kind of like the metaphor of a virtual human, we try to model certain aspects of human communication and better understand what's going on. So what we try to get from human communication, which is multifaceted, so there's multiple channels going on at the same time. So what are multiple channels? So for example, facial expressions is one channel. My voice, the words that I'm saying are different channels. The proxemics, like how do two people stand towards each other. So for example, these two guys here, very close together, their facial expressions are quite angry, and so they likely are bursting out in a fight. While the communication at the bottom looks very, very different. So this could be something like a serious relation talk or like a breakup or something like that. So this is what we can read from these different channels of communication. And what we try to understand is certain levels of affect. So like is the person happy, sad, angry, etc. We try to understand personal traits. Personal traits could be, for example, the person is open-minded or very closed-minded. They're very shy or outgoing, and we even try to understand their well-being. And this is actually one of my main research areas where I try to investigate through communication if individuals actually suffer from depression or not. And we try to provide clinicians with some flags about like if the person is depressed or not. But I'll get into that later today as an example for machine learning. All right, so a lot of my work also deals with behavior analytics, and as I already mentioned, there are multiple like channels that we need to combine. So we have facial expressions, gestures, the posture, the voice, the words that are being said, so that we need to like try to combine. And the interesting aspect of this is that I'm always trying to use machine learning to also better improve signal processing. So signal processing often has been just regarded as like an engineering discipline where lots of physics goes on, etc. But you can actually nowadays, with the amounts of data that we have access to, you can use machine learning approaches to like do the signal processing yourself. And you might have heard about this all along already with like what Google does, or what the other big companies that have hundreds of thousands of like hours of data, like people speaking, and they do speech recognition, not the traditional way anymore, where you would extract some features from the speech, but they let the machine or the neural network discover the features by itself. And so that's called like feature learning or representation learning. We're going to touch on that as well towards like further in on the course. I have another example here as well today where representation learning is happening. But just keep in mind that you can use machine learning for so many different things, and like you might have also like noticed it already. Like I think it's a new revolution. Like you can do so many things with machine learning, and all these big companies are like just doing fascinating work with machine learning, and I think you have a bright future ahead of you if you stick to this kind of like research field. To give you a couple of examples where I work on, so my application area of behavior analytics are mostly healthcare, where we investigate distress in collaboration with MIT and Cogito. We investigate suicidal individuals, we try to identify early markers of suicidality that are discoverable in the behavior of individuals rather than in like questionnaires or these complicated biomarker assessments where you need to do blood draws and stuff like that. We try to improve education through one of the projects. For example, I should really update this picture there. We have a virtual audience that teaches individuals to be better public speakers. So you can interact with a virtual human audience. The individuals in the virtual human audience react to your performance. They fall asleep if you're boring. They lean forward if you're engaging. They smile at you if they want to like encourage you to like become a better speaker or like to have more self-confidence, etc. So this is kind of like one interesting area of investigation that we work on. You can also use behavior analytics and machine learning for animations. We have developed signal processing and machine learning approaches to generate virtual human behaviors with the cerebella that was mentioned earlier in the video technology, and also we do some expressive speech synthesis. I'd like to show you a little bit like how this all feeds into like an interaction loop. So on the one hand, we like track individuals' behaviors, and we kind of, so in my group we're always kind of trying to like serve two purposes. So on the one hand, with the application, we always are interested in like what is actually going on. Do I see a person smile? What is happening to their voice? Do they get more tense or more breathy voices? And we try to like get this information and provide this kind of information to doctors who can like action on this information. They can say, okay, I think this individual is not engaging in a conversation, their smile levels are too low, they don't react to jokes, there might be something going on. Or like that was the behavior a week ago, now it's changing, they get happier and so on. So there might be a change there. And so this is kind of like the one hand trying to understand what's going on. So this is kind of like what you see here. So we track points on the face, we track the gesture, the gaze direction, we analyze the voice, we extract single facial expressions like smile levels or like the gaze for the eyes, like where is the person looking at, and we try to combine this information. This is kind of like the perception part of what we're doing, that is trying to provide clinicians or other individuals with information that's going on in the behavior. Then, on the other hand, we're interested in the interpretation, where we combine this information, we fuse the information that we gather. We do natural language processing, so we try to understand what's going on, dialogue management. But a lot of the machine learning is happening in that part of the interaction. So, so there's machine learning in every part, but I think the interpretation or like the fusion of the senses is where most of it is happening. And then on the the arc towards the output again, you have the generation that's going on, where we would decide what the response should sound like. So in the interpretation, you would choose the utterance that you want to say as a response to the human user, but then in the generation, you can kind of tune the timing, you can tune the facial expressions of the virtual human as well. Do they smile back at you? Do they frown? Or do they lean in while they say it, and so on. This is kind of the generation part. And so the cerebella is kind of happening in this area. And then a lot of the time at ICT, what we do is we have these virtual humans interact with actual humans. And so there's this communication going on for various types of purposes. And I have one purpose video for this where this kind of interaction loop is discussed, and this exact example, the SimSensei example, is discussed as an application. So this is a virtual human that screens for depression. Do you have any questions until so far about this? Right. I'll just show you a video about this technology.
Human social interaction is a little like a dance. Participants in a conversation continuously adjust their behaviors based not only on what is being said, but on what is communicated non-verbally. Decoding what these signals convey is important for how we present ourselves and how we understand others. Multisense was created by the University of Southern California Institute for Creative Technologies to enable computers with the abilities to automatically analyze and recognize these subtle human emotions and behaviors. That means Multisense can instantly quantify facial expressions, body posture, and speech patterns. It uses ICT's advanced algorithms to combine this data into a complete picture of a user's emotional state, in real time and over the long term, with a profile that recognizes changes over time. Multisense drives groundbreaking projects like ICT's SimSensei, an award-winning next-generation virtual human platform designed to improve healthcare decision-making and delivery.
Thanks for coming in today. I was created to talk to people in a safe and secure environment.
SimSensei enables an engaging face-to-face interaction where a virtual human automatically adjusts its own speech and gestures in reaction to a real person's communication cues. Live during the exchange, SimSensei will also identify signs of psychological distress, often associated with post-traumatic stress or depression disorders. It provides objective measures for clinicians during diagnosis or ongoing therapy. Additional applications of the Multisense framework include analyzing and evaluating people's gestures, voices, eye contact, and facial expressions to provide intelligent feedback that helps them improve their performances in public speaking or in job interviews. Some practice environments are even specifically designed to help improve communication skills in young adults with autism spectrum disorder. Multisense is a critical piece of the puzzle in the recognition of human social behaviors, the development of engaging educational and entertainment experiences, and the advancement of diagnostic tools. It represents how advanced technology can improve people skills, identifying hard-to-detect changes in how we communicate through our voices, words, and bodies, improving how we present ourselves, and informing the future of human-computer interaction for everyone.
Right. So, that's about me. This is the research that I do. Are there questions about this? Okay, so it's your turn now. So, what are people's majors? Or what level are you in? Did you just join? So who is in data informatics? That's nobody. That's okay. So, what are you guys' majors? Computer science, anybody? What? Okay, so you're fleeing 567 or something like that.
It's not offered.
It's not offered. Okay. Yeah. So, in 567 is a lot more theoretical than this. We're gonna be a bit more hands-on, more practically oriented, I think. And it's we're gonna touch upon most of the topics that they discussed there as well, but it's gonna be at the different level. I think, and yeah. So that's totally fine. And then who is like from a different major, totally like journalism or something like that?
Industrial.
Industrial engineering?
Civil engineering.
Civil engineering?
Environmental engineering.
Okay. So all Viterbi kinda nice. Alright. So yeah, I hope that we get this course to be quite engaging and like useful for all the different disciplines. And I think machine learning is like going into all the engineering disciplines, and I think beyond there as well. I've read many interesting articles in journalism, for example, that use machine learning, or social science is like there's a big data social science like program starting, I think, or like started already with Marteza Degani teaching a lot of the classes there. So I think machine learning is becoming more and more pervasive in all kinds of disciplines. So I'd like to give a little bit of a course overview right now. So I think I've uploaded the syllabus online to, oh, you don't see that. I've uploaded the syllabus to Blackboard. I treat this more like a living document, so most of the information is up to date. However, I would like to, for example, mention that I think this one still talks about a midterm exam, but I think we discussed that we would like to do a couple of quizzes. Like I think it's going to be like 3 quizzes or 4 quizzes or something like that. They're going to be like 15 minutes or 20 minutes each. So nothing too difficult. But what I would like to also focus on here is like early on I would like you to investigators look up possible target projects that you would like to do. And so it's kind of like a little bit of a project-driven course. I would like to have updates multiple times throughout the course, which look like draft proposals for what you want to do, the kind of like data analysis, and the kind of machine learning you would like to do. I would like to hear about that, and we should be able to discuss those projects early on with other people, and maybe we can have like short presentations of an idea, and a couple of questions, a couple of open questions, and like that maybe the groups that are working on similar things or different things could help you come up with solutions to that. So I think we have an opportunity here to be very engaging or interactive here. So the type of projects that I would like to see here are like you can have data sets from me, but there are tons of data sets out there and available for free. So for example, I'm going to come to that, like the sci-fi data set, for example, where you have like thousands of images, and these images are of, I don't know, like apples and birds and like boats and houses. And then like you could write like a machine learning experiment that tries to identify, based off of an input image, like what is present on the image. So there are standard machine learning experiments out there. There's a platform called Kaggle, where you could even engage into a competition, a machine learning or like a machine learning performance competition. There are more complicated data sets that I have available, which are multimodal data sets most of the time. So multimodal means you have multiple input sources or multiple input modalities. So for example, the public speaking data set or the depression data set has audio, video, text as inputs, and you would have to combine those input sources into making a decision. You can only use the facial expressions, but you are losing out on some parts of the data. In the Cypher, the image or object recognition data set, you just have images. You don't have text about those images. You might have a label, but that's different from an input. That's kind of like the target, what you want to classify. This is kind of like a couple of ideas here. Like one of the favorite experiments that students have done previously was the MNIST dataset where you have to recognize handwritten digits. That one's almost a solved problem in my point of view, but it's a very standard problem that you see everywhere popping up. Like if you, for example, look into any of the machine learning toolboxes like scikit-learn or TensorFlow or all these other deep learning, machine learning toolboxes, all of them have an MNIST example where you do handwritten digit recognition. So that's a bit too easy if you just copy the tutorial that they go through. I would like to encourage you guys to identify a project that you could or you would like to think about working on, and I would like you to identify people that you would want to work with. And I mentioned here like groups up to 3. Maybe we can make it groups up to 4 if you have like the strong desire to work with 3 other people.
Quick question here. For the project here, we actually need to collect the data set and put it into like machine learning algorithm and get an output out of it? Or we only need to drop the problem we need to solve, that's it?
So you don't have to develop a new problem. You can, but I think it might be a bit too much. Like what I recommend to do is find a data set that's out there, that's available readily, and you can just work with that. Yeah, yeah. And then you can, what I think I want to see in the end is kind of like, hey, we got this data set, let's say handwritten digit recognition, and we used a support vector machine on this or a neural network on this, and we got these different performances. One works better than the other, and I think this is why. That's kind of like what I want to see. Yeah.
Just apply different algorithms.
Yeah. Yeah. You can do 2 or 3 different algorithms if you have, and then like what I think is going to be important to take home from this course is like. I want you guys to understand at what point I use what kind of algorithm, and so I'm not going to do deep learning if I only have 10 data points, right? So that's meaningless, and I'm not going to do, a support vector machine if I have sequential data. Like if I have the problem of speech recognition, no one does support vector machines. You could do it, it's not going to work very well, right? So I think what the main goal of this course is to understand in what situation I use what kind of algorithm, and to be able to argue about like why we chose this algorithm over the other, and like why. So it kind of like gives you the tools to go outside of this course and apply machine learning again. Yeah. All right. So more of a applied kind of nature to this project. It's not going to be like a theoretical project where you have to like develop a new machine learning algorithm, or where you have to like come up with a new problem. It's more of a project. You identify a data set, you like develop the experimental strategy, and we're going to talk about this at length, and then you're going to report the results. Okay? All right. And then, so these are the weeks that we have here. So today, we're going to talk about machine learning. We're going to have, we're going to touch upon like a couple examples, and then we're going to have a discussion about like an introduction, like how to use MATLAB or Python for machine learning. And I think I wrote the syllabus while I was kind of like still phasing out to use MATLAB, but I haven't like really committed to not using it at all anymore. So I think we're going to focus on Python. I feel like most of the people are very comfortable with programming in Python, and I think it's kind of like the more modern, more adequate approach right now. MATLAB is nice because you can stop it at any point, you can debug it nicer, and you can plot nice plots. So there might be a component in the end, like if you're comfortable with that, to write the machine learning in Python and then visualize and investigate the results in MATLAB, or if you want to, you can use R as well. So there's no restriction on like what architecture you use in the end. Okay? Then in the second week, we're gonna talk about one major aspect of machine learning, which is supervised learning, where we're gonna introduce supervised learning on a general basis, and then kind of like talk about ways to investigate supervised machine learning. So for example, pack learnability is a theoretical concept, as well as the VC dimension is a theoretical concept about like the power and the ability of a machine learning algorithm to like solve a certain problem. We're going to talk about nonparametric methods in week 3. This is also kind of like moving and could be updated. Decision trees, linear discriminant analysis, and neural networks in this class. We might or might not do this. I think it might not be too relevant to you guys, but there is something about statistical testing that I would like to see happen in the course project in the end. So we like might touch upon that like on 1 hour or so. So because oftentimes you see machine learning experiments in conferences or journals, and like people claim, oh yeah, this performs better than the previous version of an algorithm, but you don't have the proof for it. Like it might be within a margin of error. There is no like guarantee that just because you had a slightly higher accuracy that the performance is actually better than the previous one. And you might lose out on other things like memory usage and performance, etc. So oftentimes I see like statistical errors being done in research, and I would like to avoid that, and we should have like a little discussion about like what experiments to do to show that a classifier is performing better than another one, and so on. Okay? Then we're going to talk about unsupervised machine learning, clustering, and competitive learning, some more classical approaches of unsupervised learning. Nowadays, a lot of the research is in representation learning, which is often also unsupervised. I'm going to talk about parametric and multivariate methods. Again, like there's not going to be a midterm, I think. So this is kind of like outdated. I'll find something for this week, and we're going to do kernel machines, support vector machines, and we're going to talk about graphical models, hidden Markov models, and then I hope that we have a couple of weeks at the end where we can go into the more modern things like deep learning, autoencoders, convolutional neural networks, long short-term memory neural networks, and representational learning methods. Also, like one of the methods that I'm into right now is the generative adversarial neural networks, which like make an unsupervised task into a supervised task by doing a couple of really interesting tricks, and like competing two neural networks against each other. So one tries to trick the other, and the other one tries to identify the tricks that the neural network is playing on it. And you can do very interesting generative things there. So you can generate pictures, you can generate sound, and very interesting like stuff there. We might have a brief project presentation by each group, maybe not more than like 5 to 10 minutes each group, depending on the number of groups that we have. I did not expect this many people, but I think it would be very interesting to hear, and maybe we hear from different groups at multiple stages throughout the semester. And then, as you have seen, like there are a couple of papers here that I would like you guys to read. Don't read ahead because I might actually change some of them, and I I also like to encourage you to think about methods and papers that you would like to read about, and if you find an interesting blog post or if you find an interesting paper that you would like to share with the class, I'm more than happy to change some of the paper to a reading, like what you have found, what you would like to discuss. I would like to make this as engaging as possible. Okay, so if you find, I don't know, OpenAI has really nice blog posts online, we can go through them, we can discuss those if you want. I'm very open to change those reading assignments, okay? So this should be really more engaging than just a frontal, like I select the papers that you have to read. If you find something interesting, please let me know, and we can like put it in into the reading assignments, okay? That make sense? Questions? Yes.
So what, you mean the assignments over there, what, assignment 1, assignment 2?
Yeah. So this is not happening yet. So we're gonna also have homeworks that are basically, here's a data set. Here are like the methods that I would like you to use on this, like program a support vector machine using this and that approach, or take this data set, split it into training, test, and validation set, run some like parameter optimization on this. So it's kind of like, if you take those steps from the assignments and put it into your final project, you're gonna be fine. Okay, so this is kind of like a piece-by-piece walkthrough of like what machine learning experiment should look like and what methods we can use and so on. Yeah.
Will you recommend another textbook, like machine learning textbook, for us to refer to, just in case we're lost in papers and reading?
Sure. So I recommend. So the lecture kind of follows this Alpidin book. It's uploaded on Blackboard. Don't share it. And then I also uploaded the Christopher Bishop pattern recognition book. No, did I do that? I think I uploaded the Kevin Murphy machine learning textbook as well. Don't share it. But yeah, so these textbooks should be more than plenty. And they might actually here and there exceed the theoretical level of like what we need in the class. So those are more written for like the 567 computer science course, especially the Kevin Murphy one. The Alpidin one is a bit more applied. Yeah, we're gonna go through those chapters mostly. Like there also a lot of the figures will be from the book, so you have like kind of like this anchor between those. Okay. Any other questions? All right. So what I like to do, because I get thirsty and want to rest my mind for 10 minutes or so, like we do like 50 minutes lecture, 10 minutes break, and 50 minutes after that. Okay. So let's meet back at 11.